Data visualization is on the rise everywhere in our lives, helping us track exercise, manage workflow, assess finances. But did you know it's also helping us clean up environmental pollution and contamination? Dr. Tamzen Macbeth is a remediation expert who's worked on over 100 contaminated sites around the world. And I want to ask her about the latest developments that she's helped lead in the realm of high-resolution site characterization. Tamzen, thank you for being here.
Thank you, Andrew. Glad to join.
So what is high-resolution site characterization, and how does it help us clean up in contaminated sites more effectively?
A high-resolution site characterization really represents a broad suite of tools that allow us to collect data on ever finer resolution and scales. A lot of the sites that I work on have contaminated soils, sediments, and groundwater. So these systems are inherently difficult to quote unquote see. And in order to effectively clean these systems up, it's really important that we're able to get information about the geology, the soil types, the geochemistry, how contaminants are distributed in that environment, how they're migrating in the environment, and ultimately impacting environmental receptors and potentially human health receptors. These high-resolution tools really provide better information that we can collect and ultimately create more accurate pictures to design, build, and operate effective remediation systems and ultimately restore these sites.
How are you seeing this innovation have a positive impact on the environmental cleanup projects that you're involved with?
Well, a lot of the sites that I work on are what's considered mega sites. They're very complex, they're very large, lots of impacted media, either groundwater plumes that are miles long or, mining restoration sites that cover hundreds of acres of area. So these high resolution tools are addressing some of the deficiencies that we've identified, things like not understanding geologic heterogeneity, which means the complexity in the way that soils and soil types are dispersed in the subsurface environment. That has a really big impact on how contaminants migrate. Very often, they are very discrete layers. You might have a contaminated aquifer that's 100 feet deep, but the zones where contaminants are migrating might only be a few feet thickness or very discrete intervals. So it's very easy to miss. And if you are not able to capture that, then you may be missing contaminants that are, say, bypassing your treatment system because they're not included in your conceptual model. So these high-res tools allow us to go back in, to take a look at that at foot level, or in some cases centimeter level, and really make sure that we're not missing anything in our conceptual site models. And we've used this actually on a whole number of sites to go back in, reevaluate the site, and we very often find these missing pieces that really have resulted in some previous failures, and we're able to address those now by bringing that into the conceptual site model and now modifying the remedy accordingly to really make sure we're capturing that contamination and addressing it as part of the remedy.
To what extent do you think it's valuable, or do you think it will be helpful for less technical stakeholders to be able to visualize the contamination or the contaminated site? To what extent do you see that value in this?
It really is invaluable. In parallel with the improvements in the high resolution characterization tools, so these are the tools that we're using to collect the data, there has been a parallel improvement in the models and the visualization tools that allow us to bring these really large data sets in. So we will collect data on contaminant extent, on geologic properties, on geochemistry, on hydraulics, and we can bring all of that information into a single model that then allows you to build a three-dimensional picture of the geologic system. Then you overlay, say, soil contamination, groundwater contamination, surface water contamination into a three-dimensional picture. That has all the GIS, georeference, so it'll have all the buildings, all the roads, all the things that stakeholders, that people see, they understand. It gives them a visual frame of reference. It really improves their understanding of the problem. And when we all understand the problem better, we can understand what the potential solutions are and really get the consensus and the engagement of all the stakeholders in the solution to those problems, and also manage expectations about when these problems can be cleaned up.
Well, this has been totally fascinating to hear about. I'm excited to see where this goes from here. Tamzen, thank you for being here. I really appreciated the conversation.
Oh, thanks, Andrew. Anytime.
If you enjoyed this interview and would like to see more conversations with brilliant folks like Tamzen, please like this video and subscribe for more. And if you're interested in keeping up to speed with Tamzen and her colleagues in environmental remediation, you might want to check out Breaking Down PFAS, a newsletter that brings you the latest dispatches from the front lines of PFAS treatment, emerging regulation, and R&D projects. Learn more and sign up at cdmsmith.com/PFAS.